Okie doke, here is section 3.6, and this one will sketch f prime and f double prime given f of x. So, okay, if I'm given, say, the function f of x, and maybe it looks something like this. So there's f of x. Now, if I want to sketch f prime of x, I look for particular things like, here is a critical number, and there is a critical number, because the derivative is 0 and derivative is 0 there. So I know that the derivative will be 0 there and there, so I can fill in those points. And then I just look at the intervals, and I see here decreasing, so f prime is less than 0, and f is increasing between those two critical numbers, so f prime is positive, and then out here f prime is negative again, out to the right. And so I need to make that happen. So if f prime is negative, out here, okay, I'll do something like that. It's positive between the two critical numbers, but it has to get back to 0. So it starts at 0, it has to get back to 0. And then f double prime, f prime is negative again, and so it'll go down like that, and so there is f prime. And now to get f double prime, well, it's just I start with f prime and I take its derivative, I do its derivative, and I make sure things match up. Now here, right, there looks to be an inflection point, and also the derivative has a slope of 0 right there. So that's all sort of matching up, that the second derivative should be 0 right there. That's a second order critical number. And then what's the slope of the derivative here? The derivative function has a positive slope. So that's going to tell me f double prime is greater than 0. Or another way to look at it is the original function is concave up in there, so f double prime is positive. And then similarly, the derivative function is decreasing, so its slope is negative. So the slope of f prime is f double prime, and so that'll be negative. Or another way to see it is the function itself is concave down, and so I know that f double prime is less than 0 in that area. And so positive and then negative, it's going to go, I'll use a dotted line. There is f double prime. Okay, positive there. Now, you could, do all these below each other, or just mark them well. But there's f double prime. Okay, so let's do another one. Suppose I have, a function, there's f does something like that, and then over here, maybe does that. Okay, so there's f. And so as I look at that, I'm going to say that we've got this vertical asymptote here at x equals 0. Could have been anywhere, but we'll put it there. And so the derivative, there's a first order critical number right here at the origin, but what I know is f of 0 is undefined. And so automatically f prime and f double prime are undefined. Okay, if the function's not defined, its derivative is not. Okay, so I better not have any values of either the derivative or the second derivative at x equals 0. So now, beyond that, I don't see any other critical numbers. Okay, not first order anyway. Now here I do see that maybe right there, concave up and then concave down. Okay, and so as I do this, the slopes on the left over here, they are all positive. It's concave up, so they're actually increasing. So they're starting out positive over here, but also increasing. And so, you know, maybe they look, I'll use kind of these long dashes for f prime. Maybe that's f prime on that side. They're positive, right? They're positive and getting more and more positive. They're getting higher and higher values. On the right-hand side, they're negative here. The slopes are negative, but getting less and less negative, right? So they're negative, but getting less and less negative. But they stay negative until we get to this inflection point. Well, I mean, they still stay negative, but then they get more and more negative again. And so that is also part of f prime. Does something like that, where it's always negative, but has a peak somewhere like that. And then, and again, if I have an inflection point, I should have either a relative max or a relative min on my derivative. And there I have it. So that's good. So now when I draw the second derivative, okay, I'm concave up, then I'm concave down, so the concavity changed there. Concave up is positive. So I have these, and I'll use little dots again. I have all positive things that are getting steeper and steeper. And then negative things, okay, concave down. And again, if I look at my derivative, right, the derivative's getting steeper and steeper, and so these are going down like that. So that's f double prime. And on this side, this is concave up everywhere. And again, so f double prime actually will look a lot like f prime. In that, if I look at f prime, right, it starts out with small positive values, so okay, small positive values, but f prime, well, small positive slopes. But here it's much steeper, so you know, this thing also seems to be going up. I don't know, you know, which function should be on top exactly, but this gives me an idea. Okay, so there I've drawn, I have a discontinuity in my original function, but I'm still able to draw my f prime and my f double prime. Okay, let's see, how about one more example? You know, so maybe I have something that looks like that. And so this is f. Here I'm going to have a critical number, first order critical number at this x value, but there's a point there, so the derivative will be undefined right in here, okay? So no derivative there. On this side, what I see is I have positive slopes that are getting steeper and steeper. So positive is above the x-axis, but steeper and steeper. And, you know, it looks like they don't go to infinity. They'll maybe just go up like that as well, kind of like that point. They might go to infinity. I just don't know for sure. I just know that I better not have anything here above this point. And it could be below. You know, that's the thing. I'm not sure, but I'm getting the general idea of what the derivative looks like. On this side, it's also concave up. And in this case, right, the slopes are negative. Okay, they're negative, but getting closer and closer to zero. So here, oh, and I think I was doing sort of long dashes on the last one for f prime. There's f prime. And then f prime here, it might, you know, start out at a value. It depends on how steep this is. It could possibly head off to negative infinity. I'm just not sure. But it's always decreasing, but it's heading toward zero. So I see something like that for f prime. Okay, and then f double prime, what's going on there? Well, see, this is concave up, and this other side is concave up, so I should see f double prime positive everywhere. And again, I'm not sure of this curve. It could be that f double prime is a straight line. It could be that it looks a lot like f prime. It could be that it's it itself is actually concave down. I'm not real sure, but I'll just do little dots, and we'll do something like this for f double prime. And then on this side, see, again, it's concave up. Now here the the slopes are all positive, but again the slopes are very steep there and head towards zero. And so again, I don't know how steep. So, all I know is it's kind of doing something like that. And there's f double prime. So f double prime looks a whole lot like the original function, except it's got to always be greater than zero. And instead of here, the actual function, right, went negative for a little while. Okay, so there are three examples of drawing f prime and f double prime from the original function f.